Hi class, welcome back. And now, today, this lecture video, we're going to talk about section 8.3. And in this one here, we're going to talk about the probability applications about the counting principles. In the previous two sections, 8.1 and 8.2, what we did is we talk about the two counting principles. One is we call it the permutations, and the other one we call it the combinations, right? So if you still remember the permutations, the order doesn't matter. Order does matter, and the combination is the total number of the way when you pick up the certain elements, the order does not matter. So which one take out the first, which one take out the second, does not matter. That's a combination. So what is the counting principle? So remember the reason why we will talk about the permutation and the combination is because in the chapter 7, we said when we try to find the probability of an event, so we typically in chapter 7, we wrote that out, like what are the elements in the simple space, right? What are the elements in certain events? Then we start to counter into those problems that the simple space, the elements is too many for us to write it. Just the same like the elements of the event is too many to write. So we cannot do that anymore. So that's why we're just going to count it. We use the counting principle. We say how many we have in a sample space. So counting principle is like we either use the permutation or a combination to find the total numbers, right? So we find the total numbers, so here, let me see here. Oh boy, so here, let me see, I can change it back to black. The black, they do not like it. I change it to the red, that's fine. Okay, so basically it will tell me, what is the, I can use the total number. So then the first you use the counting principle to find what is the total number of the sample space, right? And then also when you define the certain like events, I can also use the permutation or combination to find how many total numbers inside that event. So I don't care what are the elements anymore. I'm just trying to find the total, how many. So based on this counting principle, then I know if I want to find the probability of the A's here. So what is the probability of the A's here? So the probability of the A will just be, you use how many numbers in the events, then divided by how many numbers in the what? In the sample space. So it's pretty simple. So like when we try to do this type of the problem, so the first things here we need to do is let's see how many we have in the sample space. And then let's see how many we have in the events. All right, so let's take a look at some examples here. So let's, the example number 1. Okay, so for the example number 1, we have the situation is a basket. Okay, so this basket contains 7 red apples and 4 yellow apples. Okay, and then now I take a sample of the 3 is apples is drawn. Okay, now I want to find the probability. Okay, so let's take a look. The first one's here. I want to find the probability. So what is the probability? It's all red apple. Okay, and then the next one I want to find is what is the probability I will get I will get a 2 yellow. Oops. So I will get a 2 yellow. So let me erase this. All right. So let's see here. So I will find what is the probability. I will get 2 yellow and 1 red apples here. All right. So let's take a look at how we do this ones here, right? So we said the total, we have 4 yellow and 7 red, right? Okay, so what is the total? Like if I want to find the 3 apples here. So total, we have 11 apples. I'm taking 3s, right? So which one is taking first or which one is taking later, doesn't matter. So the total weight of the sample space, I want to see if I just take 3 from this basket, how many weight I have, right? So I will total weight, I have what? I have 11 apples. I want to take 3, right? So that is my total sample space, right? So let's, okay, now for these events here. So for these events, I said, hey, I want to have all the red apples. So the red apples, so here, that means, let's see how many total weight, if I get all the 3 are the red apples. Okay, so here, take a look here. I have 7 red apples. I'm taking 3. So it will be what? See the 7 over what? Over 3s, right? Okay, so now I can figure out, so I know the probability of getting the all red apples here is what? All the red apples here will just be, like we said, NA over N sample space. So we have C73 over C, what, 11 3s, right? Then you can use your TI calculator. And what I have here is 7 over 31. So it's about 0.21. Okay. Okay, so now let's take a look at the part B. The part B say I want to have 2 yellow and 1 red. So in here, I know my sample space is still the same, right? I'm taking out the 3 apples. Sample space still is 11 over 3. Okay, now let's take a look at the numbers of 2 yellow and 1 red, right? Okay, so now let's take a look at 2 yellow. So I have 4 yellow. So 2 yellow will be C4 take 2. Correct? Right? So I have the C here. Okay, so let me see here. Okay. Okay, so it's a C4 2. And then I have 3 red, 7 red. I need to have 1s here. So it's a C of what? 7 1s here, right? So did you see the keyword here? Yes, I see it. This is a 2 yellow and 1 red. So we know if the keyword is and, what do? You do the multiplications, right? Let's say it's the multiplication rules. So now you can get so now here, I will have, so the probability of 2 yellow and 1 red will just be C42, C42 times C71, and the total is C113, right? Because here, remember, right, the keyword and. So if you put it into the calculator, it will be 14 over 55. So that will be your answer. And if you want, you can change it to decimal. If you don't want, you can just leave it here, right? So that's what what is the first example we will talk about. All right. So let's take a look at the next ones here. So the next examples here. Okay, so this is an example number 2, see here, right? Okay, so example number 2, see here. Okay. So this example, we say the 26 letters of the alphabet are in a basket. Okay, a letter is pulled out and recorded, and then the letter is put back. And we said this is done in 5 times. This is done 5 times, right? Okay, so now I'm going to see, okay, so part A is here. Let me see here. Okay, so part A, this example will tell you what is the probability. Oops. Okay, what is the probability that so will spell the word will spell the word that's okay, so I need to, okay, so hold on, let me retype this. So A, yes, what is the probability will spell the word chalk? Okay, doesn't have to be that. Okay, and now let's see part B. Okay, a word starts with P. Okay, now the part C here, let's do another one here. C here, okay, a word with no repetition of letters. Okay, so let's take a look at these 3 examples here, right? Okay, so like this one's here, we said 20 letters, right? So the 26th alphabet, and now I'm going to take a 5, right? Doing 5 times. A letter is pulled and recorded, then the letter is put back, right? So letter is put back. So let's take a look at the part A here. So let's say, what is the probability this will spell the word chalk, right? So now in here, just like we did it before, 1, 2, 3, 4, 5, you do this twice. All right, so what is the probability? First letter you will choose is C. How many letters you choose? It's 26, right? So first one you choose, if it's a C, you only have 1 over 26. Then you put it back. Now the next one's here. What do you choose here? You still have 26. Now you choose H here. Then this is another 26. This is another 26, and this is another 26. Because in order to spell the chalk, so it's and, so the first one has to be C, and the second one has to be H, right? So what do you do here? You multiply it together, right? So that's because it's the multiplication rule. So total you have 26 to the 5th power here, right? So this is, you have 26 to the 5th power. All right, so now let's take a look at the second part, the part B here, right? And now the next one here is what is the word going to start with P? So here you say start with P. So that means the first letter here is fixed. So it's P, right? So when it is a P, okay, now this word doesn't have to be a meaningful word. It can be, just a word. So then you put you put the P back, correct? Then the next letters here, right? So in here you have how many different way? You still have 26 different way. You still have 26 different way. You have 26 different way. You have 26 different way. So total, you will have what? 26 to the fourth power, because when the P, this is only one chance, right? So this is one chance. And now what is the sample size? Sample size, like we say, for the N word, right? So it's like every one you can have 26 to the fifth power. So this probability will be the letter start with P will just be what? Will be 26 to the what? To the fourth power, and over 26 to the fifth power. So what is the chance you will get? 1 over 26, right? Okay. Okay, let's take a look with no repetition of the letters, right? So with no repetition of the letters, this is 1, 2, 3, 4, 5. That means that after I choose it, what is the chance I'm not going to repeat? So the first letter you can choose is 26. So if you choose P, then the next one you cannot be. So how many I have is 25. How many I have? 24. How many I have? 23. How many I have? 22, right? So because it's the end, so first one and the second one and the third one and the fourth one here. So you cannot be the same, right? And that means no repetitions here. So the total answers here, right? Your sample space still is how many? 26 to the fifth power, right? So the final answers here is no repetitions. It will be what? Will be the 26 to the fifth power. Then this is 26 times 25 times 24 times 23 times 22. So what do you get here? So it will be I put into my calculator, I think I got is 0.6644. Okay, so this is the probability, there's no repetitions. That means that all the letters has to be, different here, okay? That's pretty cool, right? It's kind of not too bad. Okay, now let's take a look at the next examples here. So the next example, this is the example number, this is the example number 3 here. Okay, so this example is after study all night for the exam, Susan randomly grabs 2 socks from a drawer containing 9 black, 6 brown, and 2 blue socks. Okay, they are all mixed together. That's typical college kids, right? So what is the probability? Susan grabs match the socks, match the pair. Okay, so this is a very interesting problem, right? So we said Susan after study, and okay, so let's take a look at how do we do this problems here. This is very interesting here, right? So in here, so inside we know inside inside her drawer. Okay, so we have 9 black. Okay, so I'm going to put this is 9 black here. 6 brown. Okay, so I have 6 brown. And 2 blue. Okay, 2 blue. Okay, so now Susan randomly pick 2. So total, how many socks we have here? So total, we have how many? So total we have 17, right? So you have 17. So the sample space here, take a look, right? So the sample space here will be what? Is like out of the total number of the sample space will just be out of this 17, you pick 2. Right, so it's a 17, pick 2. Okay, so I want to find what is the probabilities of matching pair, right? So let's think about what is the match pair. That means I could be black and black, right? Or I can get blue and blue. Or I can get brown and brown, right? So it's or I can have the black, black, blue, blue, or brown, brown, right? Okay, so let's take a look at black, black. The black I have 9. What is the chance I will grab 2? C what? C9 2. Blue, how many I have? 2. So I will grab both of it, 2, 2. And what is the brown? And the brown, I have a 6, right? So I have a 6, I grab 2. So it's a 6, you choose 2. And also, did you see the keyword? Yes, it's or, right? So that means it's black or blue or brown. So remember when we in the probability, when we see or, so what is the ors here? Is addition rules. So I'm adding addings, right? Okay, so now here is my probability. I get the matched pairs will be what? You put your sample space, right? So sample space is 17, C17 over 2. Then match pair could be C92 plus C22 plus C62. Then you can put all this into TI calculator, and I got here is 13 over 34, and so you will get not bad. So it's about 40% of the chance she will get a matching pair. That's not bad, all right? Okay, so the next examples here, next example, I typically, when we have like, if we have like a face-to-face class, I always like to do this example, especially if I have a class with like 25 or 30 students, this example will just give you the amazing results here. Let me show you what this example is about, right? So this is an example, it's a very interesting example, number 4 here. So in this example, let's say, in the class, right? What is the probability that at least 2 students have the same birthday? Okay, so what is the chance, right? So what you think, like we have 365 days, right? So if in this class here, I want to see what is the chance I ask everybody's birthday, and the chance most likely I will get a match. So the two people will have the same birthday. And like I said in the beginning, I typically love to do this example. Like we did a, I love to do this experiment when we have a face-to-face class, and that will be fun. Then you will be amazed, like especially if I have a class size more than 25, the chance I will find the two students that have the same birthday is always pretty good, okay? And so now for these ones here, it's kind of like, okay, so here I have sorry. So in this class, what's probability these two students have the same birthdays here, right? So let's see here. Let's assume, okay, in here, let's assume our class, let's assume the class, let's use our class as example. So the class size, I think we have 18 and 20 equal. Class size is 20. Let's use 20 students, right? Okay, so let's try to use our examples here. So what is the chance we will find a match here? Okay, so in here, when we try to do this type of the problems here, right? So, okay, so think about it, right? So at least the two students. So that means the two students can have a match, three students can have a match. So for the at least, we always say that if, do you remember that? We said at least. And the easier in the probability part, so we say the probability at least two match. So I can use the probability none. We can say none of the student have the same birthday. Right? Okay, so let's see here. This is 1 minus. Okay, so we assume we have 365 days. I have 20 students, right? So think about my sample space here. So in the out of the 365, every student can choose any day to have the birthday, right? So my sample space is really pretty big. It's 365 to the how many? 20 powers here. Okay, so now that means this is my sample spaces, right? So that means my every students here. So this is the sample space. Right? Now I want to say none of the students have the same birthday. That means out of these 365 days, because nobody going to have the same birthday. So I'm going to do C what? 365. I'm going to take 20 out, right? So 20 days, because all these 20 students, they have a different birthday. So I need to give each day to each student. Okay, so now you put into a TI calculator, and the answers will be 1 minus 0.5563. So this will be 0.4437. So that's why I said almost every time when I did the experiment, it's pretty successful. It's because it's kind of like it's almost the half, 50%, right? And so that's pretty good. And especially if my class size is getting bigger, like if I have a 30 student, the chance is very, very good. Okay. All right, so this one, let's do one last problem, then we will be able to get a pretty good idea how do we use the counting principle and to do the probability. All right, so next one's here. Let me see, that's the example number 4. I hope that after this, you guys be able to do the homework. I said a bridge hands is made up of the 13 cars. Okay, find the probability that a hand chosen at random contains. Okay, so part A, only hearts. Okay. What is the probability? Then part B, at least 3 aces. Okay. Probability C, exactly 2 aces, and exactly 2 kings. Okay. Okay, let's take a look here. Okay, so we said the bridge hands, right? So only hearts, right? So now, first thing is let's identify the simple space, right? So the simple space is here. Simple space is, right? So you take the 13 cards is a hand. So the simple space is 52 out of 13, right? So only hearts, let's take a look at the probability of only hearts. Okay, so in here, you put your simple space. This is C52, 13. Only hearts. How many hearts we have? 13 hearts. Then this hand of bridge is made of the 13. So I have a C13 over 13. So if you put it into the calculator, it will give you very small numbers, 1.575 times 10 to the negative 12. That means you put like 12 zeros in front of it. So it's extremely, extremely small, right? Okay, now the next one's here. I'm going to find out at least the 3 aces here. Okay, so at least the 3 aces here, right? So at least the 3. That means what I have here, I need to get 3 aces. I could get 3 aces, or I can get what? I can get 4 aces, right? That means at least 3. Now immediately I see this keyword or, so I need to add. Okay, so now let's see how many 3 aces I can have. Okay, so 3 aces, right? So I have 4 aces here. So out of this 4, I choose, so out of this 4, I choose 3. Okay, now remaining the card, not aces, I have 48, right? So I have 48. So how many, if I choose 3, how many others I have? 10s, right? Because of my, my bridge hands is 13 cards. Okay, let's take a look. What is the total chance? Is 4 aces. So out of the 4 aces, I need to choose 4. Now, only thing not aces is I have 48 left, but I choose 4, so I only have 9 cards in the, in the hands of my bridge. So you add it. And so what is the final? So you add it, right? So you add it, and then the simple space still is what? C the 52 over 13, right? So you can just calculator, see what is the, use your calculator to get it and see what is the numbers here. Okay, so the last ones here, they talk about exactly 2 aces. Also, did you see the keyword what? And, right? That means it's what? Multiplications, right? Okay, so now let's take a look. How do we see here? Exactly 2 aces. That means out of the 4 aces, I need to take 2. And out of the 4 king, I need to take the 2. So now my bridge, I have the 4 cards to take out. I still have 9 cards. But all the 9 cards cannot be the aces, cannot be the king. So how many I have left? 44, right? So 44 is 9. And because this is the end, so what I need to do here? I need to do times, right? Okay, now the same way, and what is the simple space here? Simple space is the C52 to the 13. And I will leave to you, use your calculator to calculate exactly probabilities here. So that is what we're going to cover in the section 8.3. So it's like how do I use permutation, combination, counting principle to find the probabilities. So instead of list, write it out, all the elements in simple space or the events, we can just use the counting principle to find our probabilities here. All right, I hope you guys find this fun. And so after you finish review this video, don't forget to go to do the classwork, all right? And thank you for the feedback from some of the students. They said, for example, sometimes they have a hard time to understand my handwriting. Sorry for the terrible handwriting. So that's why I start to type it out. And I hope that will help you can read better. All right, so I really miss you guys and hope we can see each other before the end of the semester. If not, we might bump into each other next in the fall, all right? But anyway, so, okay, and have fun and review the video, and don't forget to do the classwork, and don't forget to do the My Math Lab homework, right? Okay, talk to you later, right? Okay, bye.